Hello there. In this video, we're going to look at two quality measurements called Cp and Cpk. And what Cp is a measure of is the process capable? Capable meaning the process is capable of making 100% good parts within the customer specification all the time. We're also going to look at Cpk, which is a process capability index. It's a measure essentially of whether or not the process is centered or maximized because it is possibly capable, but we're making parts too big or too small or whatever. And if we adjust the process to being a little more centered, then we're capable of making good parts all the time. So the example we're going to use here is a piece of material, metal, plastic, copper, whatever, that's cut to length. The specification from the customer and what we're getting, which is X bar, is 1 inch. And the customer says they'll take 1 inch plus or minus 0.3. So the upper side of their spec limit is 1.3 inches, and the lower spec limit is 0.7. So the customer is essentially telling us they ideally want 1 inch plus or minus 0.3, excuse me. So the upper spec limit is equal to 1.3, and the lower spec limit is equal to 0.7. Now we've also, in our example, let's say we've measured the standard deviation, the measure of average error, as 0.05. Okay? So if we use the formula for Cp over on the right, it looks like this right here. It says let's take the upper spec limit minus the lower spec limit, divided by 6 times the standard deviation. So if we plug in the numbers, we get 1.3 minus 0.7 divided by 6 times 0.05, which gives us 0.6 divided by 0.3, or 2. So here's what this is saying. The upper spec limit minus the lower spec limit is the range the customer will accept. So they will accept a range between here and here of 0.6. Okay? We see that down here. What we're finding when we look at 6 standard deviations, which is plus 3 standard deviations on the high side, minus 3 standard deviations on the low side, but essentially 6 standard deviations is about 100% of what the process does. So what we're seeing here is our upper and what's called our upper and lower control limits is the range of our normal behavior, plus 3 standard deviations or minus 3 standard deviations. What we're finding then with a standard deviation of 0.05, when we take 3 of those, then our upper control limit, our upper range of normal behavior, is 1.15, and it's 0.85 on the other side. In other words, 1 inch minus 0.15. So that range is 0.3, and 100% of the possibilities fall within here. Then we can see visually, if that's 100% of the possibilities of what we'll make for the upper and lower control limit, we are always within what the customer wants. We are capable of meeting what the customer wants. Now, the measurement on the bottom here is this. When we look at that too, what does that mean? Typically, what we say is if we get a CP less than 1, we are not capable of meeting their parts. In other words, our range for upper and lower control limits is going to be outside or bigger than the spec limit range. In other words, the denominator here is going to be too big. If it is between 1 and 1.33, we're barely capable. It means we're right up against the edges. And then we always talk about ideally what we'd like to see is greater than 2. We'd like to have this range of normal behavior, upper and lower control limits, to be exactly, almost half, you could say, of the spec limit, so that we got plenty of room for any kind of variation. But that's what CP tells us, is whether or not we are capable of making parts 100% of the time within the customer spec limit. Okay? So now let's clear this out a bit and look at CPK. Okay? So let's clear this out of here. We'll put the formula in here for CPK and we'll work through the math. CPK is equal to the minimum of upper spec limit minus the average or the mean, MEAN, divided by 3 times the standard deviation, or the mean minus the lower spec limit over 3 times the standard deviation. So if you notice what we're looking at here in the picture is, I'll do this in blue now. What we're looking at here is we're looking at the range between the upper spec limit and the mean is this first one. And then we're looking on the other one between the mean and the lower spec limit. So that's number 2. What we're saying by the minimum is which one's closer to the edge. And ideally, we'd like them equal to each other because then we're perfectly centered. But what we're interested, again, is we're trying to get a CPK greater than 2 because what that means is I'm perfectly centered and there's enough room. Okay, so I can get 2 of these within here. I'm not too close to one edge or the other. So if, I guess just looking at numbers in general, let's back up for a sec. If I look at the right side here, and the space is 1.5, and the space on the left side is 3.5, what that's saying is there's a lot less space on the right side, and there's a lot of open space on the left side, then my whole process has shifted to the left. So if I look at the minimum, that's the one that's closest to the edge. And if I can get it at least 2, then I'm back to CP, that I'm still process capable. But if these two aren't equal to each other, I still got an opportunity to center things or shift back to the center. So that'll be a concept you'll probably want to replay a couple times here. So let's put some math in here. Upper spec limit 1.3 minus the mean of 1 divided by 3 times the standard deviation. Okay, so that's 100% of the possibilities on the right side. The other side is the mean of 1 minus the lower spec limit of 0.7 divided by 3 times 0.05. So I get 0.3 divided by 0.15 and 0.3 over 0.15. And it says use the minimum. In this case, they're both equal to 2 because I set it up to be perfectly centered. But we'd use, again, the minimum because it's entirely possible with a different set of numbers, I may have ended up at 1.7 and 2.3, which would tell me I have a lot less space on the left side. I can fit in 1.7 standard deviations, and on the right side, I could fit in 2.3. So I'm a little off center to the left, but I'm still capable because the CPs are high enough, I saw. So I just need to shift the process back to the right. So CP tells me if I'm capable. In other words, if my upper and lower control limits are always going to be within the customer specs. And CPK, I'm looking at these numbers to see if I'm going to be centered or not, because the perfect balance would be capable and centered. So don't hesitate to reach out if you got questions on this one. This one's a little bit of a head scratcher.